that, I'm super, super excited today to be deep diving a little bit with two of the people whose work we're particularly excited about at Foresight. So one is Richard Mallah from the Future of Life Institute, who is an AI safety researcher. He's has lots of claims to fame, inter alia, producing a pretty comprehensive map of research in that space, which I often use to link to, which is really quite amazing. And obviously you have to a variety of other projects too. And then we also have Georgios here, and I think Georgios works at, I can say, really one of the more exciting, but like, yeah, I wouldn't say it's an over exaggeration to say perhaps the most exciting, I think, organization that I think is doing work on approaches to increasing our cooperative structure with artificial intelligences. I should say you're not working at OpenMined, you're working at TU, but you are collaborating a lot with OpenMined. So just want to correct myself here, but I think from the moment that I discovered OpenMined, it was actually in a paper that Ben Reinhardt wrote a long time ago on 30 years of like a recent history of cryptography and how those approaches can help with computer security and with ultimately AI safety. I followed a link to OpenMined, and that was now a little while ago. And since then, I've just been following your work, and it's the work that OpenMined is doing is really fantastic. I'm particularly excited also to have you join, because you square the two groups that we work on at Foresight, which is both our longevity and health extension group and our intelligent cooperation group. And so with your work in more privacy preserving ways to do machine learning better on medical data, I think you really have both of these groups well covered. And we're all about intersectionality. So very, very happy to have you on. Okay, that's a very, very long preamble. I think a really good way of making like a segue into the Q&A, which should really be as decentralized as possible, is by perhaps kicking it off with Richard. And I think one way to do that is I would love to share the tech tree that I have created based on the answers that you've given. So basically, to bring people up to speed, one thing that we did at Vision Weekend is that created technology trees for individual fields and to just establish the connections across the work that many of you guys are working on. And so one thing that Foresight will be doing in the back end throughout the next year is really using the technology tree from the individual nodes that you guys are working on as a note-taking device in the back to note-take the work that you're doing in the individual seminars, and then over time creating a better way of you guys to figure out how your work interrelates with each other, and potentially also having different funding opportunities attached to this. So Richard, if this is your slide, if we want to use this as a segue to enter your Q&A, perhaps you want to tell us a little bit more about what it is that you're working on, what is an exciting end goal for your field, what are capabilities that we stand to unlock, and what are enabling technologies along the way.
Sure. Thanks so much, Allison. Yeah, it's exciting to join Foresight as a senior fellow and honorary fellow, and yeah, to be able to collaborate with more of you and sort of plug in both directions with a variety of folks. So my field is advanced AI safety. I've been in industry working in machine learning, natural language processing, advanced knowledge learning, and sort of automated refactoring and trading agents as well for about 20 years. First heard of the concept of artificial general intelligence at actually a conference called the 100-Year Starship Conference, which was 11 years ago. And I've been super concerned about all the paradigm breaks that it's going to be introducing when it does actually come about. Of course, I heard about it in science fiction before then, but I was convinced at that conference that it's actually probably going to be a very real thing this century. So rather than talking about AGI specifically, though, let's phrase it as advanced AI, because as generality increases, there's going to be qualitatively new types of AI, and generality is not just a binary event. It's not just a single singularity where we get to AGI. As a, I guess, more general, what it should do becomes a much smaller subset of what it can do than for much more narrow types of AI, or for that matter, for traditional programs. So in older types of AI, maybe we have like a search depth or something like that, which is a single parameter. Maybe in some machine learning models, we have a handful of hyperparameters. But as we move to more generality, and in the limit really, there needs to be a much richer type of parameterization when it comes to what these models should be doing. They need to have a rich understanding of what is good and bad, or is right and wrong. And so when it thinks of entirely new things to do, as these models will do, or as these systems will do, I should say, hopefully these will be things that we will have approved of, or that we would have approved of had we had the opportunity to do so. So there's of course a lot of uncertainty around timelines, around the types of risks and the best technical safety approaches. That's why it very much calls for a portfolio approach to safety. I would say that there's a few different paradigms. In general, throughout this talk, I'm going to be using some language that may be a little bit different from what you're used to, and I hope that helps to actually triangulate a little bit with respect to understandings. So I would say that ideally, if we had all the time in the world, or rather all the time before having an AGI come into existence that we might need to have something completely trustworthy, we'd want completely airtight paradigms. But it's not really clear that we have that amount of time. There are also principled approaches where we look at proofs, looking at sort of a layered approach where we might have something like SEL4 as the operating system, and have verified types of architectures go upward. And I would call these not necessarily completely airtight, because there can be things like hardware attacks or differences between models and real life, but they're still principled with respect to trying to have a somewhat complete view of the safety arena. And then there's more prosaic AI types of AI safety approaches of trying to minimize types of side effects that a system might cause, or trying to detect when there's a distributional shift or things like this, which I would say are a little bit point-wise types of solutions to things that we either have seen or very much expect with standard machine learning in how we expect machine learning to be progressing in the future. And then there's also even less airtight, just sort of exploratory AI safety, which you may have seen things like the OpenAI microscope, which super helpful type of thing to exist, super useful in understanding the types of concepts that are going on inside of neural networks, how they come together, and understanding the dynamics within them. I would say we need a portfolio approach across technical approaches, across timelines. So having all of the above of what I mentioned, but perhaps we may need something a little bit between the prosaic and principled approaches to give us enough time for the completely airtight approaches. That may be something that we encounter. So looking at the end goal, it's really having AI and AGI turn out well for life. So determining the appropriate types of pivotal acts that we'll need to actually get to a safe enough type of generality in AI, finding tangible paths to these and executing on them. And when we say turn out well for life, this is for the well-being of sentient entities in general. So humanity, of course, also animals, also potentially sentient AI or conscious AI, which I would say is not necessarily all of AGI. I think we can also have sort of tool-like AGI as well, which would not be within that sort of sentience category. And we should be very deliberate about which type we're creating. So looking at the enabling technologies here, a little bit zoomed out. So what I'm terming competitive explainable models. So explainability means a variety of different things: interpretability, transparency, explicability of sort of the internals of the model, justifiability for decisions. I'm sort of somewhat munging these all together and calling them explainable. But explainability is really important for design, for modularity, for quality assurance and quality control when creating the AI systems, for monitoring the systems, for controlling them, for auditing them, for determining how much we can trust them, and for determining liability as well. So it's not just a single dimension. It's not just a single use for explainability. I think it's really a foundational concept that's going to be used quite a lot. So there are, of course, trade-offs between levels of explainability and the accuracy of models. And so because of this, we really need to think in a way that where the interpretability of the system will necessarily be growing as the power of the system will be growing. Otherwise, if we just have sort of little lenses on little parts of the system, it's going to be a smaller and smaller part that we can just understand ourselves just by putting that microscope, if you will, on it. So there are many architectural approaches, different ones for different purposes that can help with this sort of scalable interpretability. But one concept I'd like to call out here is being able to go back and forth and leveraging that interpretability and that explanation in design. So sort of in a stepwise manner. It's not to say we shouldn't have huge monolithic end-to-end models as well. Those can be very useful in research contexts, but actually we should think maybe of research engineering as providing a little bit more of a direction for AI systems than purely the research. So for instance, the question comes up often these days in these circles of how can we get large language models doing natural language generation, writing articles and things like that in a relatively safe way, to have them stay on topic, not fabricate untruths and not use objectionable language and things like that. So actually using the a bit of a tiered approach, using this sort of back and forth stepwise explainability. A company that I co-founded created a much more sort of robust article writer than GPT-3 is able to do currently. And it did use transformers. This actually, we had a prototype around when the first GPT was released, GPT-1. It wasn't called 1 at the time, but that's what it was in 2008. And it stays on topic better and doesn't use objectionable language, doesn't fabricate things. And part of the point of mentioning this is that the approach which we use there in coming up with this writer was this stepwise manner where it's having a much more hierarchical means of interpretability and explanation along the way of what it's trying to do in terms of topics, in terms of questions it's trying to answer, in terms of subtopics, and an outline for what it's writing. So the general point there is that a small amount of human insight into how different AI techniques can work synergistically can be super useful in leveraging interpretability for scalability of interpretability. So part of my experience, as I mentioned, was in sort of knowledge representation and sort of knowledge learning. An important concept there, I think, is in how these spaces evolve over time. I think this can give us a lot of insight into the structure of these spaces. So for instance, I mentioned microscope by OpenAI. One of the concepts in there is that a given neuron might have a lot of different semantics. Sorry, I'm trying to follow what you're doing, but actually, maybe I shouldn't be doing that. There's, for instance, like a grandmother neuron, or like, you know, a car's neuron. But actually, I would say that the more sort of neural network native type of representation is in sparse distributed representations, which can be thought of, you know, if you have a super large model as something that's a little bit passe, that, you know, maybe we should just be having one neuron per concept. But when we think of how these latent spaces evolve as they get more information, as they learn more, it's really that ontology restructuring that I think will give us a lot of very useful information about how the space is structured in the first place, and how sort of, you know, never-ending learning, which will sort of be necessary for these types of AGIs, will be able to you know, work safely. So I'm not saying that will be an end-all and be-all of safety and interpretability. I'm just saying it's a very useful direction that is not getting enough light at the moment. Moving on to scalable preference modeling. So there's, of course, many trade-offs among different kinds of fairness, even in today's AI. If we look at, you know, discussions of things in the criminal justice system, or getting loans, or even, you know, Facebook recommender feeds. I think there's something like 20 different kinds of fairness that folks within sort of the near-term AI safety and sort of AI ethics space have flagged. And the point is that there's lots of different trade-offs among all of these. And actually, there's also trade-offs among, you know, accuracy and robustness, interpretability, fairness overall, privacy. I'm sure Georgios will address some of the privacy versus accuracy trade-offs in the second half of this session here. But my point is, we need to be providing human insight and human oversight at appropriate levels. So a small amount of richer data can help to structure biases for what will inevitably be sort of more unsupervised bulk learning. So essentially a distant supervision is probably what's called for. And again, there are also trade-offs among different values that are held, you know, across the population, and even within individuals, there's conflicting values. And as AI gets more general, what the system should do, again, becomes a much smaller subset of what it can do. So we can think of there being a spectrum right now, where in sort of the near-term AI safety and AI ethics space, there's relatively fixed types of things that folks are checking for. Specific kinds of fairness, specific kinds of, let's see, privacy preservation. And then if we look at the very long-termist community, they eschew those and say we should be pretty much learning from all the data that humanity has ever generated. You know, look at the entire web, look at all YouTube, look at all books, and try to generalize from that on what values really are for humanity. But I think there really needs to be a bridge between those two ends of the spectrum. So considering that individuals and different groups do have different values, we also can't wait for consensus on what values to be building into an AI system. Really, we should be looking to parameterize these values. Otherwise, we're going to either have one type of black box where it's these relatively fixed types of checks and metrics that we have, or the other type of black box where it's relatively opaque because it's such large number of just large tensors that we're learning, and it's not very explicable. So again, we need a bridge, we need a scaffolding. And so also quickly on being able to like watch lots of humans or trying to understand from lots of books and the whole web and such about what values are. We can of course watch lots of humans, but there's many layers to what humans are doing. So many layers of instrumental preferences, of instrumental goals. And we really need a principled approach for combining the top-down and bottom-up approaches to understanding ethics. So I'll direct you to my one key challenge you want to see solved box there, which is a call to this community and overall of having a richly represented sort of normative ethics data set and benchmark. So why normative? So again, systematic approaches to ethics, although they're not complete, when some ethicist or some philosopher writes a book of what some ideal ethics should be, it's just essentially their opinion. It's probably not even a complete coherent opinion, but it does provide a lot of useful terminology and concepts. Very few people live entirely by any one of these books, but they generally are more coherent than the descriptive ethics that humans individually are showing, of themselves. And so the point there is that we can have an ensemble of interconnecting scaffolds onto which descriptive ethics can hang. So again, descriptive ethics is, what do people actually think in daily life? What types of decisions are they making? What types of values are they prioritizing? And so I've done something similar with concepts and relationships more generally with text, having sort of overlays of ontologies and dynamic ontology alignment and auto refactoring of one or more ontologies together. Essentially, these are unstructured annotations on text, or in this case, on the descriptive ethics. And there's also subsymbolic knowledge representation that we can sort of take from that descriptive ethics and then put onto that scaffolding, which provides more of that symbolic interpretability. So really what we want here is a good multimodal data set, because data sets provide the ability to create benchmarks, and it's those benchmarks that the research community in general uses to propel new technologies, to try new architectures, and to compete with each other. It's key to get into that R&D horsepower. So people are working on not just improving computer vision and computing and translation in these standard benchmarks, but also how can the system be more ethical? And really a very important part of this is having the annotations as to what ethical theory something is referring to. So the fact that one shouldn't kill a potato is valid in terms of an ethical determination from, let's say, a Jainist perspective. But we'd like to be able to tag that and know that it's a Jainist perspective. And likewise, a negative utilitarian, which I'm sure there are many in the world, although hopefully not too many, might think that snuffing out somebody who's unhappy is a very ethical thing to do. The point is, we'd like to be able to disentangle these different ethical ideas and concepts, And again, not saying this is be all end all. I'm just picking a few things that I think are sort of underrepresented in the dialogue here. So sort of going back to those enabling technologies on that third one here, reliable coordination mechanisms. We've talked about some, and it's a pretty exciting discussion that we were starting to have. In general, at each level, we'll be needing mechanisms to make sure that we're finding the synergies where we can. So finding appropriate sweet spots and synergizing needs and capabilities, values and resources. So for instance, at the geopolitical level, we'll need parties to find a new way to be in positive sum dynamics rather than playing games about positional dynamics. So yeah, getting more of that prototopian dialogue going. Very happy that that's being included in the book there. Yeah, Drexler's concept there is so key, I think, to the geopolitical dynamics that we need. So we can have some foresight about the risks and be able to work together at the highest levels. Even among multi-stakeholder groups that are international, where the groups generally think that they agree on things, oftentimes there are variations in values. So the sense of privacy in Canada might be slightly different than it is in the US, which might be somewhat different than in Europe. And even within Europe, there's going to be slightly different variations among states.
Richard, 1 minute warning.
Oh no.
In case you want to either take questions also or briefly discuss the capabilities, just know.
Sure. So downstream, we want to get some state where we're able to be bootstrapping and have sort of a phased approach to safety, where we can have confidence in being able to scale up. So consider a broad landscape of safety dependencies. What seems accessible and what can we reasonably trust, which type of system to be helping out with when it comes to addressing additional types of considerations within safety. So it's sort of a ratcheting approach that I'm suggesting here. And once we get some decently capable AI, it could be put toward reducing risks in general. So that could be helping things on the X-Hope side, as well as reducing, hunger and global warming and geopolitical tensions, things like that. And we also need to be thinking early on about, managing the windfalls that come here, to be able to put in place early on capabilities and affordances that will be, positive for the range of entities, but we shouldn't be leaving this for later, because otherwise it might not happen when there's weird, fast dynamics going on. They need to be pretty guaranteed. Yeah, happy to take questions.
All right. Thank you so much, Richard. That was quite, I know that like many of the things that you mentioned are individual items that FLI and a few other organizations are actively working on. So thanks for taking us really on a walk through the park of many individual projects that are actively being worked on in the community. Maybe we have time for one question before we go to Georgios, and I think Christopher Goddard had a question here. Christopher, if you want to go.
Sure. So my question was just in touching on the values ethics. Yeah, hope you excuse, it's early morning here. So just by the challenge that you're posing the group regarding, some sort of normative data set or framework for describing values or ethics in an unbiased way. would that be related to the idea of defining policies for reinforcement learning? Now, I know obviously machine learning is a very, very broad subject, but yeah, that's basically my question.
Yeah, I think certainly one can take an ethical system or some ensemble of ethical systems and treat that whether as hard constraints or soft constraints, can treat it as a regularizer, can treat it as, in a variety of different ways within an RL system. And I think that, yeah, certainly, that will help to inform some of the approaches to, for instance, figuring out the differences between negative side effects and simply side effects.
Thank you.
All right, lovely. Okay, so we've now gone all the way out to long-term AI and to a few ways along the way. And I think Richard also touched on a variety of different things that, Eric, a few others are working on and that we discuss in the book, including Pareto-tropian preference alignment and including a few key challenges that we have to solve along the way. I now want to make it kind of like ask you to do a mind switch to make it pretty actionable. As I've said at the beginning of this talk, I think one of the organizations that I'm super excited about that is actively working on specific concrete ways in which we can do privacy preserving machine learning that will make us allow us to make better decisions in the really, I think, important trade-offs that we'll face in the future is OpenMined, and Georgios is a 2022 Foresight Fellow who is working and who has been doing fantastic work with OpenMined and who's also actively working on applying privacy preserving machine learning for medical applications. And so in this regard, he is really taking a lot of the ideas that we discuss in the book and really making them actionable in the real world already. I will share a few references to a little bit of the work that Andrew Trask, who founded OpenMined, is doing that we reference in the book here as well during the presentation. But for now, Georgios, I'm really happy to have you here. And thank you so much. And I'm really excited for the shift from like long-term considerations into how does it actually affect the systems that many of you guys are actively building and working on. Again, I'll share the slides that I created based on your answers to the email here, and then we can hopefully break out into a Q&A. All right, lovely.
Hey, thank you very much, Alison, and also thank you, Richard. It feels really hard to sort of measure up after hearing all of that really exciting research and all of these future directions you referred to. Let me briefly introduce myself. Please call me George. I know the name is complicated otherwise. I'm an assistant professor at the Technical University of Munich. I'm also a research associate at Imperial College in London, where I got my accent from. Also, as Alison mentioned, I lead the research team at OpenMined. OpenMined is a large open source collective. We have more than 10,000 individuals, researchers, and scientists, and just interested people. And we work on developing open source software and providing free education with regards to privacy preserving machine learning. And I'd like to give you just a very brief sort of glimpse into what privacy preserving machine learning is and does. If I maybe, just for a little bit of audience interaction, just a show of hands, even virtual hands, how many of you are actually technologists? Okay, so I'm seeing about half. The other half has probably already gotten bored of me and left. But okay, thank you. So I'll sort of give a moderately non-technical introduction to what privacy preserving machine learning is and does. At its base, sort of the sense of the essence of privacy preserving machine learning is a trifecta of technologies. And these technologies aim to allow us to derive insights from data without ever having to see the data or share the data. And these technologies are cryptography, for one. They are technologies based on objectifying privacy guarantees, and they're technologies based on shared and distributed governance over data. And the motivation for developing these techniques is that we need more data than ever before, obviously. And on the other hand, though, we sort of have this, this clash between this requirement for data and the fact that data should remain sort of the sole and irrevocable property of its owner. And There's obviously no essential governance over data when you copy and transmit data. There might be legal governance, but no essential governance because of something we call the zero copy problem, which means that data sort of self-diminishes in value the more you copy and distribute it. And at the same time, obviously, the information contained within is seen by more and more eyes, which might be something you don't want. And on the other hand, we want obviously data owners to be able to decide how much can be learned from their data, and also be at liberty to permanently and irrecoverably destroy the data when they feel that the utilization should no longer be possible. And we are convinced that no data sharing system in existence is going to sort of solve this problem, and no contractual interaction between parties will really ever prevent a misuse of data. It may penalize the misuse of data, but it won't be able to prevent it. So the aim of PPML, or privacy preserving machine learning, is to be able to give a mathematical guarantee that is sort of as safe as cryptography. So you should be able to trust the guarantee given by these techniques in the way that you can trust that it's not possible to break them before sort of the end of their known universe. Okay? And the reason why we're specifically interested, because I work for an Institute of Artificial Intelligence in Medicine, and I'm also a trained radiologist. So interestingly enough, the reason for me getting into this field was that we literally have hundreds of tools in medical AI, especially in the field of radiology. In fact, about 50% of FDA-approved medical devices based on artificial intelligence are actually radiology focused. And there's recent work showing that most of these are not trained on more than 1,000 data sets. And just to draw sort of a similarity to real life, if your doctor was trained on only 1,000 patients, you would likely not trust them to perform a complex operation. And a pilot with 1,000 hours of experience is usually not allowed to be the captain of a modern airliner. So this sort of data insufficiency is a really tangible problem in medicine. So the quantity of data. The other things are evidently the quality of data that we get, because medical data is so strictly regulated, obviously in Europe. The upshot of that is that we end up having access to only data from a very specific distribution. And that's the distribution of patients who happen to have been treated at our hospitals. And if we're lucky, we might get a few other hospitals. But to be able to train sort of fair algorithms who don't discriminate against other ethnic groups, for example, or genders, we really also need more diverse data. And a lot of diverse data is really hard to get in medicine. And that's sort of the quintessential and fundamental motivation for developing PPML techniques for medicine, because it turns out that with these techniques, you don't really need the data themselves or itself. What you really need is the insight from the data. And Andrew Trask, who Alison mentioned, has this very nice way of putting it. It's when you go through an airport and you put your bag on a conveyor belt and it's scanned by an X-ray machine. Somebody has the liberty to look into your bag, but in fact, what you really want is one piece of information, namely, is there something dangerous in this bag? And when we're talking about, for example, narcotics, there's sniffing dogs, and these sniffing dogs, they can put their nose in the bag, and they can tell you, okay, is there narcotics in the bag or not? But they can't tell you, oh, there is X, Y, whatever else in this bag, because they don't speak English. And in the same way, what we want is a class of algorithms and to avail ourselves of a class of techniques which allows us to derive the critical insight from data without seeing all the rest of this. Many of you might have heard of a technique called federated learning, which is becoming quite big lately, which is the idea that when you want to train an ML model collaboratively, you instantiate this collaborative learning protocol, where a series of data owners, a set of data owners, all have some compute resource which is available to them. They put their data there, and some training coordinator then sends the model to each of these data owners. The model is trained and updated, and then aggregated every so often and updated, and then sent out again. And the whole thing is continued for many, many cycles up until everybody is in possession of a trained model without ever having to sort of cede governance of the data, because the data never leaves the computational node. And this would be a great idea if it were fully privacy preserving, but it turns out it isn't, because when you actually send anything to somebody to look at their data, be it a model or be it a scholar or be it whatever else, it turns out that they can learn something from this data, and models can learn from that data, and they can be reverse engineered to actually produce some data when they're reverse engineered, which is the original data that we're trained on. And there's many examples of this. Language models, for example, which were trained on large language data sets, if trained incorrectly or not using these privacy preserving techniques, can be made to sort of expose sensitive data like social security numbers. And we have shown in our own work that models trained on medical imaging can be reverse engineered to reproduce high detail medical images, showing, for example, that a patient is missing a breast secondary to an operation, which firmly sort of places that patient into a group of patients with cancer, which is obviously very sensitive. And this problem doesn't stop even when the models are just deployed for inference, because it turns out that even in this sort of black box setting, you can still probe the model and perform what we call membership inference, or even steal the models, which might be the intellectual property of somebody. So even these sort of data governance techniques like federated learning are insufficient measures of privacy protection, and this motivates us using mathematical techniques to protect privacy and incentivize data utilization without requiring data sharing, and while formally protecting privacy. And I've obviously said the word privacy a couple of times now, but I haven't yet formally defined our notion of privacy, which might be slightly different from the way the word is the term is colloquially used. And formally speaking, when we say privacy, we mean the ability to control a flow of information within a set of appropriate social norms. And this harkens back to a definition given by Helen Nissenbaum under the contextual integrity moniker. So very essential to our definition of privacy is the notion that privacy can only exist within a well-functioning society. This means that if you have a dysfunctional society, what you consider private might not be considered private by society or by the government. See, for example, totalitarian regimes. And in other cases, in well-functioning society, something that somebody considers private might be considered non-private by the government, because the greater good demand that this information is revealed. For example, if you have some illegal data, then it might be in society's interest to reveal this data. So privacy is only well-defined within a well-functioning society and within these social norms and boundaries. And to sort of turn this statement around, privacy also occurs naturally wherever society exists. So if you're a hermit living, in the forest or in a desert, there really is no well-defined notion of privacy, because there is no one else. So there is no information exchange. And to sort of, maybe connect back to Richard, the notion of privacy that we have isn't concerned really with what causes the information to flow. For example, it might be an ethical mandate, because we might be, very, very definitive about the fact that we have an ethical obligation to train an AI model to help patients, or the kind of the properties of the data. The question that we're trying to answer is how much information flows, and we're trying to answer this in a quantitative way. So privacy in our terms is not synonymous to what we call secrecy, which is more like a switch you can flip on and off. And if you turn it off, no information flows. If you turn it on, all your information flows. And it's not the same as confidentiality. It's also contingent on the availability of secure systems and secure platforms. For example, if you leave a hard drive lying around and then you forget to lock the door, that's not a very good measure of privacy protection. But the formal definition we use is a definition given by Dwork and colleagues, or at least attributed to Dwork and colleagues, and that is the definition of differential privacy. And this is sort of my main area of research and expertise is this field of differential privacy, and that's why I'd like to take you on a sort of a mini tour of what differential privacy tries to guarantee. And the idea here is basically that we are able to derive some sort of sensible insight from a collective of individuals, while at the same time, every one of these individuals has the opportunity or the ability to plausibly deny that they were part of this collective. And to sort of exemplify this, we will use a technique which is over 40 years old by now and goes by the name plausible deniability via randomized response. And the idea is very simple. You want to find out how many individuals in a collective partake in some sort of behavior, but you cannot trust them to be truthful about that. For example, some socially unacceptable behavior. And if you ask them, some of them are probably going to lie to you, and you're interested in getting as accurate an estimate as possible. So what you do is to give them 2 coins and to tell them to please go in another room where I can't see you, and then please flip both coins. And if the first coin ends up heads, then you will come out of the room and tell me the truth. But you won't tell me what the coin told you, you'll just tell me the truth. And if it falls heads, you will look at the second coin and you will deterministically output an answer based on the state of that coin. So if it fell heads, you will tell me the truth, and otherwise you will lie to me. And the idea here is that if we do this with enough individuals, we have some measure of noise overlaying the true distribution of answers, but this is a pretty, calculable risk, or a pretty calculable excess noise that we have, so we can still make a fairly accurate estimate. But more importantly, the individuals themselves have the option of saying that I was asked a question and I acted as the protocol bade me, and I lied because the coin told me to lie. So they don't actually have to reveal their secret piece of information. And this is sort of what differential privacy does on a high level, and what we do to make this usable for machine learning is to usually add noise. And last but not least, so we have some time for questions, I'd like to briefly touch on cryptography and cryptographic techniques, because I mentioned these at the start. And chief among them, I want to mention a technique called secure computation, or secure multi-party computation. And the idea here is that you want a quorum or a party of individuals to be able to compute the answer to a question, but you want sort of n-1 or some smaller amount of individuals to not be able to reveal the answer. So you need a quorum to sort of reveal the answer. And David, to answer your question, it's differential privacy. I can write it down afterwards as well. But yeah, to continue, what you want to realize is shared governance over some data, because only through consensual governance is it possible to reveal this secret data, but without consensus, you're not able to. And the idea is that what you do is that you're able to split data into so-called shares, and then you distribute these shares around, and the individuals perform some computation on their shares, and the protocol has the property that if you add up the shares, for example, after the individuals have performed a computation on them, then you get a correct result back. So correctness and perfect secrecy are 2 of the properties of secure multi-party computation. So this is sort of a really, really quick walkthrough over what we do. I'd encourage you, and I'm happy to share some material showing how we apply these techniques to machine learning and deep learning, and bringing them to clinical routine. We've shown this to work extremely well on algorithms for medical imaging analysis, which sort of have competitive performance, classification performance to human radiologists. And the idea here is basically that if we use these, techniques on a large scale, we can be able to provide access to models which have been trained on larger data sets to more people. For example, in developing countries where radiologists are not available, we're able to train models on decentralized data and then offer remote diagnosis as a service, without having to be worried that an undue amount of private information is being revealed in these cases. So yeah, thank you very much. I think we have a few minutes for questions. I'm also very happy to yield some time back to Richard because he barely had the opportunity to answer questions. So I consciously stopped a little bit earlier. So yeah, I'm really happy to also give you some time back, Richard.
Thank you so much. This was wonderful. I'm hoping that maybe in the Q&A we can also tackle your challenge a little bit, but I think maybe to kickstart off a bit of a Q&A, Richard already had a question to you because I think it would be lovely to tie your two talks together. Richard, you go.
Sure. So with respect to trade-offs, I know that within differential privacy, you're sort of stochastically coarse graining, you're stochastically perturbating. And so you do lose both accuracy and precision. So my question is, are there ways for managing those trade-offs in a way that's sort of parameterized? Like, are there either standards or are there norms on how to, think of the requirements for all the stakeholders, or perhaps for different shards, different subsets of those stakeholders, and handle those parameterizations differently?
Thanks. That's a very important point you're touching on. So what we evidently know and has been shown many times is that the sample complexity of differentially private learning is significantly higher than non-private learning. And in fact, we know from empirical experimentation that to obtain the same accuracy, you need roughly about 1 order of magnitude more data than you would need. And it's evidently a very valid question to ask that if we need 1 order of magnitude more data, is this then still privacy preserving? And solving these privacy accuracy trade-offs is a very difficult sort of challenge. I think there's 2 techniques which I can offer up. Both of them, funnily enough, rely on the existence of public data. One is knowledge distillation and sort of the idea of training an ensemble of teacher models from which to distill knowledge into a private trainee. And the other is as simple as using transfer learning for training models which have been pre-trained on public data, on private data. The problem is obviously that this is quite a strong assumption, and you would be absolutely right. Everybody would be absolutely right to state that this might be too strong an assumption, in fact. The other option that we have is, because you said the magic word parameterization, is to actually rely on sort of inherent properties of the model. And some of the work that we've been doing lately is to actually rely on complex valued models with complex valued weights, which inherently sort of have a little more flexible latent spaces because of the sort of extra degree of freedom that complex multiplication allows to train real valued tasks. So we just zero out the complex input, a component of the input, and we train with a real valued input that using a complex valued model. And the nice part is that we can use the same amount of noise in the complex and the real valued case because of some properties of sort of the spherical complex valued Gaussian distribution. And we get the same privacy guarantees, but we get about 2% better accuracy. And this is also one idea to work on. But to conclude, just very quickly in the outlook on sort of general machine learning theory, the question is much more complex than that. It's about the trade-offs between generalization and memorization, the question of structure in latent space, and sort of why private learning sort of prefers to converge to worse global minima, which generalize worse, or in fact, whether the problem is in fact memorization, because there's less memorization, we get worse learning, and there is some work which indicates that you need a bit of memorization for learning. And these are all sort of very new avenues of research, and we're actively working on them. So I can't conclusively answer yes.
I have a question for you guys, which is both of you, interestingly, independently from each other, have as your challenge both data and ethics. And so, Richard, you had having a richly represented normative ethics data set and benchmark. And then Georgios, you had improved data curation, preparation, discussion of ethics and data valuation issues. So I wonder how, if you want to disambiguate the two, or George, if you want to share a little bit more about like what actually does that mean in relation to the work that you are doing?
So I don't want to monopolize, so I'll answer really briefly so that Richard has an opportunity to obviously answer as well. For us, I think one issue is interdisciplinarity. So obviously being rooted in medicine, we work a lot with the Institute of Ethics in Medicine, which is a very important collaboration to us. I think as correctly sort of observed, the requirement for privacy doesn't still answer all the questions about ethics. So I think that a lot of research is needed to determine appropriate ethical standards by which we need to, for one, train the models that we train, and also by which we handle the data that we use, in order to actually make these privacy-preserving technologies and the ML models trained with them actually comply with our normative ideals. And as correctly stated before, Richard said, these are very different, for example, from country to country. And finding a universal sort of ethical standard would be a very challenging, but also very interesting sort of venue.
So that goes back to my question of having sort of a format, if you will, for the parameterization. So because it does vary from country to country, you could potentially have that as an input to the model, right? And so coming up with ways to refer to those, you know, as essentially normative ethics, would seem to be a useful thing, you know, even in your case.
Certainly, yeah. I think that sort of, from my understanding, what you're referring to is actually sort of parameterizing the behavior of the model in terms of some ethical consideration, right, and penalizing it from deviating from these ethical norms, which I think is exactly the way to go, to be honest. And obviously, I think if we can parameterize it, then we should, and we should sort of make it as formal and perhaps also as trustworthy by that means as possible.
It also reminds me, I think, Richard, you were there maybe in the previous discussion that we had earlier today with one thing that Jamie Joyce from the Society Library is working on is just also to first cataloging disagreement about certain specific ethical issues and just actually first cataloging even the argument space that different people have. And so maybe that's a way of how to disambiguate a little bit between what different philosophers and different cultures even have as their ethical underpinning and get perhaps to the root causes of that. All right. I don't know if perhaps we could finish off with, I don't know if you off the cuff have any specific relevances. So Richard, for example, you at the beginning mentioned OpenMined briefly in your talk. So is there a way in which you can already see that one of your nodes fit together? Is there a way that they could provide comprehensive or like at least like a stepping stone for helping each other's work? I know, for example, that if we want to level all the way up to having AGI turn out well for life, we definitely depend on the work that George is doing. So perhaps if we want to close with a little closing statement on that, that would be awesome.
Yeah. So as I mentioned, you know, we do need a portfolio approach, and there is a lot of uncertainty around timelines with respect to AGI, and so really what we should be looking for sort of sweet spots of collaboration might be things that are relevant in the near term for near-term systems that we would expect to be able to scale to much more capable systems. And so, yeah, certainly privacy preserving ML and the various types of you know, cryptographic coordination and cryptographically safe sort of co-computing, if you will, I think are super interesting directions for collaboration there.
Any additions to that, George? He's nodding, agrees, I think.
Yeah, I couldn't agree more, actually. I think there's nothing to add to that.
Lovely. We also had a really interesting point here of just like we have different types of software licenses, perhaps we have different type of ethics licenses at the beginning, and people could at least be quite upfront about which one it is that they're using. Okay, well, we're now already a minute over time, and we barely scratched the surface. I'm really grateful, Richard, for you joining and just giving us like the lay of the land of like a little bit of the consideration that FLI, that you in particular are thinking about when you think about how to make AGI turn out well for life. George, I'm super grateful for you joining and giving us a bit of an understanding of where the state in privacy preserving machine learning is to date, and how we can scale it up. And I know that like many of the kind of keywords that you mentioned, from differential privacy to federated learning and so forth, are things that I think we'll be seeing much more of in the next few years, at least if things are going well. And so I think those are still fields that are deeply undervalued, even though I think OpenMined is receiving lots of really well-deserved attention for their work in this area, and you have fantastic courses that I think I really welcome everyone here to check out. But I think that, yeah, your work will only become more important, I think, as we scale, and we certainly need a lot of that also in our biotech group as we try to do collaboration on different types of advancing the medical field better. So thank you so much to both of you.